June 23, 2010. The completion of the Dream Building has changed the Singapore skyline. Beyond the scope of imagination, it's a structure that few believed possible to build. A 21st century architectural miracle, the Marina Bay Sands Hotel. Singapore is a city with diverse and adventurous architecture. Marina Bay, a prime coastal site. It's the gateway to Singapore. The government's decision to develop the area centers on turning it into a tourist hub. The site was put out to tender. The Las Vegas Sands Group of the U.S. was finally selected as the company to carry out the project. The Las Vegas Sands Group proposed a dramatic and distinctive design for the site, a building that would capture everyone's attention, a landmark, an icon. It's unique. With 2,561 rooms, it's more than just big. 57-story towers with SkyPark reach 210 meters into the sky. 3 towers consist of 2 legs. That largest inclination is a staggering 52 degrees, 10 times greater than the Tower of Pisa. Topping it all is a massive boat-shaped SkyPark. The size of 2 soccer fields, it is at 343 meters. 20 meters longer than the Eiffel Tower is tall. It's not only eye-catching, it's a challenging design. Even the architect of this 21st century Tower of Pisa wasn't sure it could be built. 14 companies vied to claim their place in architectural history. Just 4 made the shortlist. Korea's Sanyong Engineering and Construction, as well as companies from Japan, France, and Hong Kong. Sanyong Engineering and Construction won the competition. Their bid was not the lowest, but they were the only company that guaranteed to complete the construction of the unique incline towers within 27 months. The Marina Bay Sands Hotel could only be built through Sanyong's expertise with modern architectural technology. Because the hotel stands on reclaimed land, has a unique structure, and needed to be built in a short time, new and innovative building methods were required. Because the hotel was built on a landfill, the first challenge was to build a circular diaphragm wall that could withstand the high pressure of both the water and the soil. In the early stages of constructing the complex underground structure, transportation routes for materials and equipment had to be secured. At the same time, the stability of the foundation and the time constraints had to be considered. Sanyong chose the circular diaphragm in order to overcome such issues from the groundbreaking stage. Square and circular diaphragms were tested to compare the differences. When water was poured into a square diaphragm model, it immediately collapsed under the pressure. The circular diaphragm model was more robust. Under identical conditions, it barely changed shape. As such, a circular diaphragm proved to be more effective than a square diaphragm in withstanding water and soil pressure without the use of separate supports being installed and removed, resulting in a significant reduction in the construction period. The next challenge was to begin construction on the framework of the hotel with a maximum inclination of 52 degrees. According to the blueprints, the tower leg with the steeper slope must stand on its own until it meets the other leg at the 23rd floor. Sanyong conducted a test to see how high a building with an inclination of 52 degrees could stand on its own. When they reached the 8th floor, the structure collapsed. Therefore, a way had to be found to hold the 2 legs up until the crucial 23rd floor. This was not possible using any existing construction methods. Propping up the 2 buildings would be the simple solution, but simulations showed this also failed. Large cables like tent ropes could be used to hold up the legs, except this was impossible because the cables would need to be anchored in the middle of a nearby highway. In the end, SsangYong engineers came up with the innovative idea to build the cables inside the legs. After numerous reviews and simulations, the post-tensioning process began. The post-tensioning process inserts cables directly into the building. When the cables are taut, the building can stand on its own. First, SsangYong placed a maximum of 96 cables within each wall and tightened them to hold the building in place. Once the cables were in place, anchors were embedded 4 to 5 meters under the buildings so that the cables could be tightened as each floor was built. The weight of the building was shifted to the other side and bracing was set up to provide temporary support and ensure the safety of the construction. 3 sets of 8 temporary bracing props were set up at the 8th, 14th, and 20th floors. However, the post-tensioning process had limitations. Tightening the cables meant applying pressure, but if the pressure is too strong, then the concrete would crack. To counteract this problem, SsangYong also made use of reinforced concrete. The walls needed to be thicker to hold the cables, but reinforced concrete made it possible to make them thinner, thereby satisfying both design and safety needs. Furthermore, hundreds of sensors were placed at strategic points in the props and the building to monitor the angle and pressure. The sensors instantly sent SMS text messages in real time to 20 engineers when even the slightest problem was detected. When the 2 legs meet at the 23rd floor, the towers can stand unsupported. The post-tensioning cables and temporary bracing is then removed. However, a problem still remained. The immense vertical weight of the structure once it was finished was a major challenge. Because it leans to one side, a tower will topple over even at the slightest impact. The higher the inclination, the less weight it can hold up. This meant that the straighter leg had to support more of the weight. The solution lay in the transfer trusses built into the walls, each weighing 3,000 tons. Transfer trusses help distribute the weight of the building evenly. SsangYong installed transfer trusses in the walls of 12 floors between the 16th and 28th floors of Tower 1, which has a maximum inclination of 52 degrees, and 4 floors between the 22nd and 25th floors of Tower 2 with a lower inclination. The transfer trusses were moved to their respective levels by crane. They were then positioned on each floor and assembled to create a huge structure. 60% of the weight was distributed to the tower with a lower inclination, and 40% to the tower with a higher inclination to form a safe structure. Once the most difficult part of the inclining structure was completed, the construction of the framework began to pick up speed. Construction of the framework for a hotel with a 52-degree inclination was completed perfectly in 18 months, with innovative creativity and technology utilized throughout. There was still more to do. The element that would define the hotel as a new Singapore landmark still remained: the SkyPark. When the Marina Bay Sands Hotel was complete, the boat-shaped SkyPark floating in midair would catch everyone's eye. The SkyPark would be a dream space consisting of a swimming pool and spa, with a 360-degree bird's-eye view, a restaurant, and an observation deck poised 210 meters above ground. It weighs a staggering 60,000 tons, equivalent to 43,000 sedans, with 7,700 tons of steel framing. What is even more surprising is that the 67-meter observation deck, the size of a Boeing 747, cantilevers into thin air with no apparent support. The hotel's central elevators also contained a secret to reducing the construction period. Jump lifts. The use of jump lifts means that from the initial stages of construction, elevators are built into the basic framework so that they can be used to transport materials. This also eliminates the task of installing elevators later, resulting in a significant reduction in the construction period. Sangyang drew on various processes and technology that no one had ever thought of to accomplish the feat of raising one floor in a mere 3 to 4 days, and to build a monument of 3 levels underground and 57 stories above ground on reclaimed land in just over 2 years. It was a truly massive project. 32,500 truckloads of concrete and approximately 20,000 kilometers of steel reinforcement bars were used. If laid end to end, the bars would stretch from the North Pole to the South Pole. This mammoth hotel with over 9,000 sheets of glass on just one side cost a staggering $890 million. Furthermore, working in 2 shifts 24 hours a day, as many as 6,000 workers from more than 10 countries clocked in 12 million accident-free man-hours. This was an unprecedented record, and yet another miracle in the history of architecture worldwide. The grand opening of the Marina Bay Sands Hotel on the 23rd of June 2010 was a day that marked a new page in the history of architecture. 1,200 international reporters gathered to cover the opening ceremony. A dream hotel that not even the architect who first came up with the design believed could really be built. But a miracle happened, and imagination turned into reality before our own eyes. There was a time when the question in architectural engineering was, who could build higher? Now, the question is, who can construct an unconventional building? Faster, safer, and closer to what imagination can conjure. Sangyang will continue to do its best to create masterpieces in architecture to be remembered throughout the history of mankind, based on original ideas, cutting-edge technology, and a passion to challenge the impossible.